Hello everyone and welcome back to the course. In today's lesson, we're going to have a glance on a very important concept in the entire world of mathematics. Today's lesson is going to be about rate of change of a function. This concept refers to how a function actually changes at a given point. This is also known as the instantaneous rate of change. And graphically, this represents the tangent line of a function at a given point. The rate of change of a function is obtained when we take the average rate of change of the points x, f of x, and x plus h, f of x plus h, where h is a positive value. Thus, the point x plus h, f of x plus h, is to the right of the point x, f of x. Thus, if we take the average rate of change of those 2 points, we get f of x plus h minus f of x divided by x plus h minus x. And once we simplify, we obtain the expression f of x plus h minus f of x divided by h. We know that such expression represents the slope of the secant line that passes through the point x, f of x, and x plus h, f of x plus h. And when we approach the point x plus h, f of x plus h, towards the point x, f of x, we do this by approaching h equals 0. And once we do this, we can notice how the secant line transforms into the tangent line at the point x, f of x. Mathematically, we write the limit when h goes to 0 of f of x plus h minus f of x divided by h for obtaining the rate of change of the function. Let us consider the motion of a particle described by the function f of t equals t squared, where t represents the time in hours and f of t represents the distance traveled by the particle in kilometers. Remember that the change of distance with respect to time is equal to velocity. Have that in mind. Thus, if we want to know what is the instantaneous velocity of this particle at any given time, we need to solve the limit when h goes to 0 of f of t plus h minus f of t divided by h. If we apply the proper substitutions, we obtain the limit when h goes to 0 of t plus h squared minus t squared divided by h. Now, if we expand the expression t plus h squared, we obtain t squared plus 2th plus h squared. Thus, we have the limit when h goes to 0 of t squared plus 2th plus h squared minus t squared divided by h. And if we simplify, we obtain the limit when h goes to 0 of 2th plus h squared divided by h. If we factor by h the numerator and then cancel out the h, we obtain the limit when h goes to 0 of 2t plus h. Thus, if we substitute the value of h to 0, we obtain that the limit is equal to 2t. So we can say that the actual change of the function f of t equals t squared is equal to 2t, where t represents time in hours. Then at t equals 1, we obtain the value of 2 times 1, which is 2. But remember that we computed the instantaneous rate of change of this function, and as the change in distance with respect to time represents velocity, we are obtaining the instantaneous velocity at a given time. So this value of 2 represents 2 kilometers per hour. Thus, at t equals 2 is 4 kilometers per hour, and at t equals 3, we obtain a change of 6 kilometers per hour. We noticed in this lesson that the rate of change of a function represents how a function changes at a given point. Graphically, it represents the tangent line of a function at a given point, and that is a concept that you need to have in mind for next topics. We also mentioned that this is just a glance on the concept of rate of change, and we're going to see more about this in the next course on calculus. As always, see you in the next lesson.